Helen dropped 2 balls X and Y into the tray of flour. Okay, obviously the heavier one is going to create a bigger dent than the smaller one. Just by a concept of imagination, you drop 2 balls on sand or on any flour, is going to cause a bigger dent if your object X is bigger or object Y is bigger. It's a ball, right? She recorded the depth of dent. What do you mean by dent? So this is what I mean. Something like that. And then this one caused a bigger dent. I do not know. Is it Y? Because yes. So this one, the average was only 1.17 cm. The other one was 3 cm. And what does the depth measured? It was just this distance here. She measured, okay? So she measured and she found that, hey, X average 1.17, Y 3.33. How do you get average? She actually dropped the ball, take it out, make the sand smooth or the flour smooth again, drop again, measure again, make it smooth again, drop again. How many times? 1 time, 2 times, 3 times. That's the experimental technique that we've been teaching you, right? Repeat your experiment, take the average for more accurate results. Don't do it once. Once you may have thrown the ball wrongly and then this guy dented more and you thought, hey, this is a heavier one. Making a big mistake. So you need to repeat until you are sure you can be accurate. Okay? Based on the results, which of the following statement correctly explains? Correct means choose the correct statement. More frictional force was acting on X than Y. Frictional force, gravitational force, gravitational force. That's what you need to pick out first. When you drop something, you are measuring the gravitational force, right? How much force it is going down with to actually cause this dent. Nothing to do with the friction, right? Friction is when you are moving and 2 objects are rubbing against each other. This one is just hitting, it's not rubbing. Okay, so therefore I will not go for frictional force. I'll look for gravitational force because that's the aim of this experiment. Next, which one, C or D, should I choose? Okay, let's read. More gravitational force was acting on X. More gravitational force was acting on Y. So Y or X? Y created a bigger dent with a bigger depth, 3. So this is the heavier one. More gravitational force was acting on Y. So D is the answer. Right. Okay. Andre used his finger to flick the striker from point A to point B on a carom board. Okay, so you got a picture there to flick a striker. How many of you have seen a carom board before? It's a game played with a lot of coins, so-called coins like these, and then you use a striker to hit them into the 4 holes and you score based on your colors, usually black and red. Okay, you should try and find out what this game is all about. It's a nice game. Okay, if you want to read about it, read about it. If you want to buy it, you can still buy it from Toys R Us and so on and play with your family. I used to love this game as a kid and it really teaches you a lot of physics and science because you're supposed to use the correct amount of force to hit this striker, to hit these coins at an angle where the coin will actually enter the hole. You see, they are not near the hole at all. How do you want these coins to go into the hole? You got to hit them at the correct angle. And it becomes more interesting when all these coins are spread around everywhere and then you start choosing the coin that you want to hit and put them in holes. You can even hit them backwards. So that's why it gets really interesting. But here, Andre is just playing for a start. The game has not started. He's testing. He uses some force. He pushes it this way. So flick means to push the striker out and it lands at B. Okay? State the force that is on the striker as it moves from point A to point B. So, 1, the striker does not start floating. It stays on the board. Okay? So this is actually a wooden board. So it stays on the board. So gravity is acting on it. Force number 1. Number 2. If there was no friction, this striker will be going past this B and going here and going here and going here and everywhere. It will never ever stop. Friction is the only rubbing action that can make any object like this stop. So friction must have been there. So what are the two forces? Gravitational and frictional. Well, we learned this in 2 of our F4. Okay, so you should have written these two, identified these two, because where's the elastic spring force here? No. And where's the magnetic force here? No. So we've got the other two only. Great. Now, without moving or changing the surface of the wooden board, what can Andre do to the board if he wants the striker to move further than point B, using the same amount of force to push the striker? Well, he wants it to move further than point B, maybe to somewhere here, okay, point C. You want it to move further, you apply more force, right? You push it further, push it harder. But here he says same amount of force. So the only way is to reduce these forces here. Gravitational force, well, we can't reduce. We've got to pray to God to ask him to reduce gravitational force some sort. Unfortunately, but frictional force, we can do something. Remember in our lesson where we tried to reduce frictional force, we put wheels, we put lubricants, we use streamlined body. Which one do you think you can use? Can you use wheels? You can't, right? You're cheating. So can we use small little tiny ball bearings that do not really affect the game and cannot be seen? That's called powder or talcum powder, right? When you put it on the board here, it forms like little tiny beads, where you know you have beads in your soap as well, tiny beads lying around on the board. And what happens is this striker starts to sit on these beads. Well, it's actually so small that it's can't be seen. It's virtually impossible to see it, virtually like invisible, right? So usually what people do to make the board smooth is to put a lot of powder on it so that the striker can fly around without much friction. So that's the answer that I'm going to write, and then I'm going to explain that answer as well. First, I'm going to put talcum powder, a powder on it, because the striker is going to sit on little tiny beads of this powder, therefore reducing friction. I want to hear you say reducing friction. I want to see you write reducing friction. Okay, there you go. Reduce, okay, the friction. There you go. Reducing the friction. That's the key one. Okay, why? How do you reduce? You add powder. So that's mark number 1. By adding powder, it reduces friction. That's mark number 2. That's it, explained. Okay.